Welcome to the Microchip Is podcast. Join your host, Mike Maynard, as he learns about the technologies, products, and people that make microchip technology what it is today.
Welcome to the Microchip Is podcast. I'm Mike Maynard, and today I'm learning about what microchip is in the world of power and analog. I'm speaking to Fionn Sheerin. Fionn is the product marketing manager at Microchip. Welcome to the podcast, Fionn.
Thanks, Mike. Appreciate it.
It's great to have you on the podcast. Can you tell me a little bit about your role at Microchip?
So I'm a product line marketing manager. My responsibility is to figure out what things customers need and organize our development and engineering teams to support that. So we get heavily involved in new product development and heavily involved in our customers' applications when they're asking for our help.
And working in the field of power and analog, that's enormous, a huge range of different product categories. Can you tell me briefly what are the main product families that Microchip offers?
So analog is a very big tent, and Microchip has a lot of different analog offerings in different areas. We've got signal chain management products, linear amplifiers. We've got some sensor products. We've got motor drive products, motor control products, and all manner of communications devices. So my personal expertise is DC-DC conversion. I work with our linear regulator products for DC-DC conversion. We also have linear regulator with filtering capability products. We have switching regulators that do buck or boost, or even in some cases, buck, boost, step-back, flyback control of DC-DC conversion. We have analog controllers that can regulate that DC-DC conversion. We have MOSFET drivers and other interface devices that allow our DSPs and microcontrollers to run a digital power conversion and still interface to the power MOSFETs and the feedback signals that they need in those power conversion applications. And then we also have power modules. Power modules are DC-DC converters, but they have integrated magnetics. So you get your switching converter with the inductor all in one package. And that is a very simple DC-DC conversion solution for a lot of applications.
That's an unbelievable range of products. It's incredible. I'm interested. You mentioned things like linear regulators, and yet Microchip is really known as a digital company because of its microcontrollers, I guess. So can a company like Microchip that seems to be digital actually be successful with analog products?
We're very successful in analog. Our reputation for digital controllers is well earned. That's where the company got its start. Memory and microcontrollers are our bread and butter products in a lot of ways, and those are the things we were successful with first. But from a corporate perspective, it made a lot of sense not to stop there. So for more than 20 years now, the company has been developing and branching out into analog solutions. We've been doing it through acquisitions of other companies. We've been doing it through organic development. We started with products that fit next to our microcontrollers, things like watchdog timers, supervisors, voltage references, amplifiers for generating feedback signals to the microcontrollers were obvious expansions for us. And we knew what those products needed to be because we knew the microcontrollers that were going to read those signals or drive those signals. And then, from there, we just kept growing. Linear regulators, excellent example of a broad product portfolio we've developed, partly organically and partly through the acquisition of Micrel and Telecom Semiconductor and Supertex. And the product line is broad. It covers quite a bit of our customers' application needs, especially interfacing to our microcontrollers. We are one of the top 10 linear regulator suppliers in the world. And because we're such a good microcontroller supplier, sometimes people don't notice that. But it absolutely is a strength for us, as is DC-DC conversion and analog in general.
Wow, I'm surprised. I'd had no concept Microchip had been in the analog game for 20 years. I'd obviously heard of some of these acquisitions, but not all of them. And it's clearly built an incredible portfolio. Presumably, though, some of your real strengths are actually where it comes to combining digital and analog together. For example, the digitally enhanced power products. Can you tell me a little bit about these products and Microchip's product family?
I can. Microchip is a leader in digital power. Our microcontrollers, and in particular our DSPIC DSCs, have been digital power solutions leading the market in that area. Some of our engineers give talks teaching other people how to develop digital power algorithms at conferences like APEC. We know closing the loop digitally. We know how to write those algorithms in code to generate your voltage regulation or your current regulation using digital algorithms. But we also know how to do that in analog. We know how to use amplifier-based feedback control systems, from our constant on-time controllers to fixed PWM controllers, to generate those regulation signals and implement that control. And when we try to bring those two worlds together, we got the digitally enhanced power analog portfolio. That uses an analog control loop, so it's easy to understand, and you don't need to get into the digital algorithms, which obviously we can also support. But some clients don't want to deal with that level of code. So we use an analog control loop, and then we use a microcontroller on the same chip in the same silicon to configure how that control loop is operating. Things like the voltage reference, the operating frequency under and over voltage lockouts, current limits, current regulation set points, duty cycle limits itself. You can program all of those, set all of those in registers from the microcontroller. It's not complicated code to update a few registers, but you get the same analog control loop, you get accurate regulation of your current or your voltage, and you get customizable behavior, in particular differences in operating conditions or fault conditions. So you get customized fault reporting capabilities, customized fault response capabilities. You get the ability to change how you're operating your control loop based on the ambient temperature. For example, in LED drive, sometimes clients want to control the current going through the LEDs to different current levels depending on the temperature that those LEDs are. It gives them better control over the color. In other cases, they want the ability to use the same circuit for different LEDs from different bins. So they have to tell what LED bin they're using and adjust their current set point. And those dynamic adjustments, while the circuit's operating or during startup, can all be made by the microcontroller to the registers. And then you get the same analog control loop driving it, so you get very predictable behavior and a very classic power design. Much easier to use than closing the loop digitally, but obviously closing the loop digitally brings still further enhancements, and so we do support that DSPIC, DSC-based loop closure.
And these digital controllers, I mean, I guess they're giving you things like the opportunity to build switching regulators with higher performance. Is that really what you get when you move into more complex designs?
It's performance in power supplies is kind of a, which thing do you care about question. In terms of accuracy, there are very accurate current regulation, voltage regulation products in our portfolio that are strictly analog, plug and play, no code required. In the digital side, we can maintain that same accuracy, though sometimes it takes a little bit more work to do, but it is doable. But the real advantage of digital is reconfigurability and reusability. One power design can serve multiple applications, which with minor tweaks to the code to adjust for, what that voltage needs to be, what that current needs to be, what those lockout conditions are required in that specific application. And so the reusability is better. And in particular, the fault reporting, fault responses are much better when you can code those yourself in digital as opposed to getting a fixed analog behavior.
It's interesting to me because one of the things you've said, I think 2, 3, maybe 4 times, is these products make it easier for people to create power systems. So is that a big focus of Microchip to actually make the designer's job easier?
Certainly. We, between our products and our tools and our customer support, our goal is to make the design activity for our clients as easy as possible. That's, in a lot of cases, why people choose Microchip, is we have better support, better documentation, more accurate documentation, or easier to use devices. This is a strength for us compared to some of our peers. And it's, relates back to our history. We started as a microcontroller company. Making our microcontrollers easy to use was what made us successful. And that attitude has carried on even in our analog product families.
And that's interesting because you don't just provide chips, you also got power modules. Is part of the reason of providing power modules to give people a more complete, easier to use solution? Or are there other benefits to engineers when you actually buy the module from Microchip?
Ease of use is the main benefit for modules. There's also a benefit in our module products, particularly the power module products, in terms of EMI and EMI characterization. So when you take that control loop and you put it in the package, you put it on the same substrate, you put the inductor in the package, and you overmold the whole thing. Now we've got the whole power supply, including all the noise radiation points, all in one place. And we can take that and we can test it against EMI or EMC conditions. And then we can report those results out and generate those reports for use by our clients. Our power modules are all CISPA rated. They all have that EMI testing completed. And you can know what EMI that module is going to produce on your board before you buy it, before you set it down. Compared to putting a bunch of discrete components together and making your own power supply, then you have to EMI test that device, that board yourself. And sometimes EMI can be very unpredictable. Sometimes you can do everything right and still wind up with a spike at an unfortunate frequency and have to go back and redo your layout, swap components, switch passive devices, start snubbing things. It can be a real pain in the butt for a designer. And unfortunately, in a lot of cases, it could be very late in the design cycle before you find that problem. And then you've got a schedule issue and angry management and a delay to release. The power modules solve a lot of those problems.
And presumably that's quite an investment. I mean, Microchip's known as a chip company, but you've got these capabilities to manufacture modules. That seems quite a big commitment from Microchip to the module business.
Definitely. The supply chain behind a module is more complicated than the supply chain behind a piece of silicon. We make all the pieces of silicon that go into the modules. So we could sell you all of those components and a client could put those together on a board and do their own layout and do their own testing. But we've done all of that for you in the module. And so that can be a big shortcut for some of our clients.
And another way you make things easier is by providing tools. Can you tell me a little bit about the simulation tools that you offer to help analog designers?
We are very proud of our simulation tools. In particular, MPLAB Mindy Analog Simulator is a fantastic tool for power conversion. It's also a great tool for other applications as well. That is based on the simplest Symmetrics engine. It has the Symmetrics simulator, and so you can use that for your linear designs or other analog circuits. You can pull in models to that product and simulate whatever devices you want to in there. The simplest Symmetrics engine doesn't have the same convergence issues that a traditional SPICE simulator does. It's a little bit easier to get the results you want in a closed loop environment where those feedback paths are potentially doing confusing things that can make it hard for the simulator to figure out what's supposed to be happening. And we've got all of our devices preloaded into that tool, along with a lot of libraries of generic parts or magnetic parts. So that really simplifies DC-DC simulation and can get reasonably accurate results before you start going to hardware and board layouts. We also have a service to do layout verification, our power check service. So if you start with a simplest design and then you go through a layout, you can submit that to our design check service. We can review the layout for you and then pick up the parts through us or through one of our distribution partners and get a much higher likelihood of first pass success when you start dropping things down on the board compared to if you just go straight to hardware from scratch and hope for the best.
That's really interesting. I didn't know about that. You've actually got a team of engineers who'll review customer designs to help them get it right first time. Is that what you're doing?
Yeah. In particular, the service I was mentioning was a layout review service.
Mm-hmm.
So you get your design set up the way you want it. You draft a board layout for how that's going to look. And then we review that with seasoned power engineers that have done a lot of power conversion designs, and they can look for red flags in terms of like how the grounding wires are run, the separation between power and analog and digital grounds on the board, the traces you're using for the high power paths, the arrangement of the feedback resistors of the feedback path, look for any coupling or noise potential hotspots related to that feedback to make sure you get the accuracy you're looking for, good transient responses, and first pass success in terms of noise, accuracy, and control.
That's awesome. It's got to be quite reassuring for customers that they can get experts to review their layout. Can I just go back to the simulator as well? Because that's also really important. You've actually gone and chosen a company to work with as a partner. Do you want to talk about why you've chosen to use the Simplex engine rather than build a simulator tool in-house?
So we did look at doing our own internal simulator. And certainly we have the engineers, we have the expertise. Given a long enough time frame and a large enough team, we could have built our own design simulator. But we probably couldn't have done it better than a company that already did it and was already in the industry doing it and selling that as a product. So instead of building our own simulator from scratch, we partnered with the Simplest Symmetrics team, and we use a version of their tool as our Mindy simulator. And they're happy with that arrangement. We're happy with that arrangement. If you don't have the capabilities you need in the Mindy simulator, then you can purchase the Simplest Symmetrics Flowbone tool and get access to all of those features. And then you can take your design files that you've already been working with in the Mindy analog simulator and move them directly to the full package simulator. Start running them right away. So whatever your needs are and however that scales over time, you can start with the Mindy simulator and you'll still be safe long term.
Yeah, that's amazing. Obviously, Microchip customers are getting access to a lot of functionality from the Simplex tool, and they're getting access to it without any charge because you make it available for free.
No, the MPLAB Mini analog simulator tool is completely free to download, and it's preloaded with a bunch of circuits that already feature some of our products and might meet some of your design needs. So you can tweak them as you need to, or you can do simulations from scratch with the component libraries that are there, or bring in other libraries of parts into the Simplest tool and run those as well. It's a very powerful engine.
This has been fascinating. I feel like we've only scraped the surface of some of the products that are available from Microchip in the power and analog area. I'm also interested in talking about your role in terms of developing new products. Do you actually sit down with other business units, understand what's needed to support their products, and work together to build basically a system solution?
Absolutely. There are applications that need more than just power conversion. And sometimes the implications of the power conversion in the circuit are more than just the power supply. As an example, we have another division in our company doing PCI Express products, and they're working for large PCI Express systems. They want fast data rates, they want multiple channels, they want big interfaces, and that requires a decent amount of power. And so we have power supplies tailored to match to our PCI Express products to help those systems work with those dynamic needs. It's a similar example in data centers. We have a data center business unit that's working data center products, and some of these are fairly specialized processors. They're over time shrinking the geometries on those nodes, which requires lower and lower voltages to bias all these processors. With AI being what it is and data centers exploding the way they are, the processor need in those applications is very real. There's lots of processing that has to happen. And the better processors require lower voltages, and they sometimes have big demand spikes. There's big changes in the load on the power supply when it goes from doing a bunch of computing to not doing very much computing. And so these small geometry processes, they require low voltages, and they also require very tight tolerances to those voltages, because even being a little bit high, a little bit out of spec, you'll damage the device, or being a little bit low and a little out of spec, they won't have the power they need to do the processing at the speeds they're trying to do it, and you'll wind up with soft errors or under voltage lockouts or shutdowns, or there's all kinds of problems when the voltage input to those processors is not perfect. And not just the baseline accuracy, but the dynamic accuracy. When you get those load steps on the processor, you have to stay in that tight tolerance window. It's a very difficult power conversion application that didn't exist 5 or 10 years ago. People didn't need voltages that accurate at those low levels. So we've got our power solution products tailored to some of those applications based on what those other business units are telling us they need out of their power supplies in order to satisfy their customer demands. So when you're buying with Microchip, you can get total system solutions. You can get the power supply that matches the processor's requirements. And you know that they're tested that way. You know that they're developed that way. They were spec'd that way from the inception of the product. And that greatly reduces the risk of having a problem in a system later in the design process.
That's pretty cool that Microchip's actually powering some of the latest AI technology. I'd like to know, are there any other, interesting or cool applications you've seen of your products?
Well, we couldn't talk about interesting electronics applications today without talking about automotive. The automotive needs for power supplies, the automotive needs for semiconductors in general are growing dramatically as they put more and more electronic features into what was classically a mechanical product. And in a lot of cases, that's not the expertise of the automotive tier one suppliers. A lot of these companies, their historical business was mechanical devices, connections, cables, motors, and now they're trying to add diagnostic reporting and intelligence and communication. The automotive space is a giant growth area for electronics in general. The opportunities for power in automotive are dramatic. The exterior lighting and some of the smart lighting systems some of the OEMs have developed really do make for very interesting power conversion applications with very specialized requirements. Some of the processors going into automotive have very specific needs in terms of the power supplies that drive them, some of the sensors, and then on top of that, you've got the communication networks that need specific power levels, and the whole thing's got to run off of the automotive battery voltages, which are very wide input tolerance specifications to accommodate for huge variations between battery to battery or over the battery lifetime or transient spikes from the alternator. It's a very rough environment. It's a very noisy environment on the power supplies, but you can't let that translate through to all of the intelligence on the other side of the board, because that's no less sensitive in automotive than it is in data center or computing applications.
That's cool. I think it really illustrates the range of applications of these power products. We need to wrap up now. And so one of the things I'd really like to conclude with is whether you've got any advice that listeners can actually use if they're about to design a timing system.
Simulate your designs. Simulate your designs before you go to hardware. It'll save you tons of effort over your projects.
Great advice. Thanks, Fionn. Lastly, we've covered such a range of things, but if there was one thing you'd like someone to take away from this interview, what would that be? I'm going to guess it might be around ease of use.
Microchip is here to help. We have services to help. We have products to help. We have tools to help. We have websites full of white papers and reference designs and application notes. Use our website, use our resources, take advantage of all of that information our engineers have been compiling on these products and systems. Avail yourself of that knowledge, and it will save you time.
That's great advice. I mean, it's clear Microchip is set up to try and make power design easy. It's been fascinating talking to you, Fionn, and I'd be interested to know if there's someone listening to the podcast they'd like to find out a bit more, what would be the best way for them to get in touch with you?
You can find my profile on LinkedIn, send a message on LinkedIn. If I see it, I will get back to you as quickly as I can.
That's perfect. Thanks so much for your time, Fionn. It's been fascinating talking to you, and thank you for being on the Microchip Is podcast.
Thank you, Mike. Take care.
Thanks for listening to the Microchip Is podcast. Please follow us on your favorite podcast platform to keep learning about the many technologies, products, and people that make Microchip what it is today.